So let's now proceed with the centroid of plane areas. So I think we already know how to um, graph equations, and then we also solved the different methods of getting our plane areas. So again, recalling the methods that we have discussed so far in getting the area of the plane regions or the bounded regions. So we have the horizontal strip and then the vertical strip. All right. So again, there are two methods. So we have the horizontal strips in which you literally create a horizontal strip, and then again you have the vertical strip. So again, as an important reminder for using the strips. So again, you need to verify the strip if it is uniform all throughout the bounded region. So meaning, for example, if you're using the horizontal strip, so the right side must be touching the same equation wherever you put your horizontal strip in the bounded region. So the right and the left equations must touch the same lines or curve. So same goes for your vertical, or let's say vertical strip. So anywhere you put it in the bounded region, so the upper and the lower part of the strip touches the same equation or function. So I think in Centroid, so we'll just have to manipulate the formula a bit. And I think this one is also useful in your next subject, or let's say in one of the major subjects, which is statics of rigid bodies. So probably that will be in the first semester of your third year. So centroid of, let's say, any kind of material, let's say steel. So it's important to learn this topic because you'll be using this one again in your higher subjects. Okay, so to start off, let's have an introduction. So usually, um, centroid is just the center of gravity for the body. So most likely this will be the main topic for your major subject, which is again statics of rigid bodies. And I think the centroid topic will also be useful in your steel design and your reinforced concrete design, wherein you're going to determine the centroid, or let's say the neutral axis of the different types of materials such as beam, columns, slab. So you need to determine the center of gravity for those kinds of materials, especially if your beam is, let's say it's a T beam, so it's letter T, so meaning it's a combined beam and slab. So, so you're going to look for the centroid of this kind of material. So magmana siya ang challenge later on. But for now, we'll just learn how to determine the centroid of different kinds of area, especially irregular shape ones, because I think that's what's the purpose of the integral calculus. So probably um, since most figures, or let's say since most polygons have known formulas for centroid, so I think the integral aspect will come into play if you're going to look for irregular shape figures such as this one. So T-beam. So so you don't know. I mean, there's no such formula for this kind of figure, diba? But for example, if you have a square, so it's pretty simple, diba? So it's just h over 2. Or let's say if you have a rectangle, so pretty much standard formula for these types of polygons. But again, for irregular shape figures, or let's say composite polygons, so most probably the integral aspect is more powerful compared with breaking it down into different kinds of components, such as, for example, kanina yung T-beam, you're going to break it into different types of polygons, such as, pwede ka mag two areas, di ba? So two rectangles. So you may also do that one because it's also part of a process. It's a very it's Varignon's theorem. So pwede gyapon siya. Okay. So the centroid of area is analogous to the center of gravity. So um, area is analogous to center of gravity. So most likely the process is the same, but this one is just area. And we're not just using gravity here. We're using an area of a particular region. Okay, so the concept of the first moment of area is used to locate the centroid. So first moment of an area, so probably that particular this term here, moment, you'll appreciate this more when you go to your static subject. Okay, so this is what the center of gravity looks like, formula for center of gravity. So if you want to understand the formula, summation moment about y, this is moment. That's what the term earlier was referring to, moment. So moment about y, so meaning I think the simpler term for moment would be torque. So I think you know torque, diba, from physics. So that's what moment is. So you're going to have a specific point where you're going to create a torque or moment, diba? So force times the moment arm. So probably that's the general idea of torque or moment. So notice here that in the formula, you're going to have here bar x and then bar y. Okay, and then W is the force. So again, since this one is in the concept of center of gravity, and again, gravity is another um, force, diba? But it's just a constant force because it's gravity, diba? So usually this one is weight, that's why it's W. So if we're going to define further the formula, so bar x meaning the location of the centroid with respect to x, that's why it's bar x, times the total weight, that's why it's big W, is equal to the summation of x delta W. So this summation here is composed of individual components summed up into a larger component. So meaning this one is the whole picture. This one is the individual component. So let's say imong gitagi-tagi ang kuan, di ba? To make it easy, let's say you have a box here. Then you're going to cut it into different pieces. So let's say the centroid is this one, di ba? This one is bar x. So on the right hand side, the integral aspect, di ba, the summation of x delta w or the integral of x dw is representing all the different individual boxes kaning gagmay. Yan na siya yung mga individual po ng mga centroids po. So muna siya ang pasabatan niya. So it is representing all the different components of the, di ba? The whole is equal to the individual parts sum up together. Sum of individual parts. So the whole is equal to the sum of the individual parts. So that's how you're going to interpret the formula. And it's the same as the bar y formula. So bar y, so meaning that's the center of gravity in the y aspect, the direction going towards the center of gravity in the y component. And then again, it's equal to the sum of the individual parts of the y components of, so for example, in this box, so y na senta, di ba? So the individual parts will have different centroids in the y direction. So that's how you're going to interpret your formula. Okay, so properties of centroid. So centroid must lie on any line of symmetry of a homogeneous figure. So usually we're going to solve for centroid as long as the material is homogeneous, meaning it's one type of material only or one type of figure only. So probably this one is useful in your next subject, but for now, since we are focusing more on the area, so this homogeneous figure won't really matter for now because again we are solving for a bounded region, di ba? Okay, so this one is a centroid, so all figures have a centroid. And again, as what I have discussed earlier, the total area. So again, instead of weight, so we can now call it as area because again, it's analogous to the centroid of area. So again, the whole is just equal to the individual components. The whole is equal to the sum of the individual components. So again, my example earlier is an example of this one. So let's say we're going to have the T beam again, T beam, because it's letter T, di ba? So let's say the centroid is here, di ba? So this one is representing the entire area, and then probably this one is, let's say, the letter R, di ba? For example, A1, R1, let's say if we try to cut this one into two portions, so this one might be the other centroid, this one might be the other centroid. So you're going to have it as R1, then this one is R2. Di ba? So area 1 and then area 2. And of course, the whole area of the T-beam will represent the big letter A. So again, as you can see, so it's just the whole equal to the sum of the individual components. Okay, so this will be the formula. So that will be the formula. So um, again, you just have to memorize the formula. And I think the easiest part here is to define the how we're going to um, create steps in going towards our final answer. So if we try to analyze um, our formula, so let's say we're going to use the x bar first or bar x. So you can also read it as bar x. Area is equal to the integral of x sub c and then differential area. Okay, so notice that you have here an area in the formula. So meaning we're going to look for the area. And then this one is we're going to look for the centroid x sub c of the individual components. So how we're going to do this is we're going to be looking out for the strip that we're going to use in order for us to determine the area that we're going to use. Okay. So in simpler terms, I think we can further define the formula in this aspect. So instead of xcdA, so we can try to define it as um, integral of x sub c, and then for example, whichever strip you're going to use, it should be, let's say, for vertical, y top minus y bottom dx, right? So that's how we're going to be dealing with the differential area. So that's why it's just differential area, because we don't know what particular strip we're going to use in the problem yet. So it may be horizontal strip, it may be vertical strip. So again, that's why uh, it's it's represented as differential area, because again we don't know which kind of strip we're going to use here. So again, it may be x right minus x left. So again, it will depend on um, the the formula. All right. So probably what I can say is um, the first thing that we need to do is to draw the graph. So I think all the steps necessary to look for the area are our first process in our solution. So look first for the area, this one, look first for the area, and then the rest will just follow, especially the x sub c and the d sub a. Okay, so again, x sub c and y sub c will depend on which strip you're going to use in the problem. So for you to be able to appreciate the formula, so let's go to an example. So let's say we're going to locate the centroid of the bounded region by x squared equals 8y and x minus 2y plus 8 equals 0. So kindly take out your calculator again, because again I don't have any calculator with me and we're not going to finish if I don't get the answer. Okay, so I have created the graph already, because again, para it won't take much time sa atong discussion, because the discussion is not about graphing but it's about locating the centroid. So for the graphing aspect, again, I leave that one to you on how you're going to graph your equations. So again, if we try to analyze the given functions, this one is a parabola, this one is a line. All right. So next is we're going to look for the area. So again, sorry. So again, we don't know yet what particular type of equation strip we're going to use, but in observation of the graph, it's obvious that we're going to use vertical strip, because the top portion is touching the blue line or the blue graph. The bottom function is always touching the red graph, whichever I place my vertical strip in the given bounded region. So aside from that, also, if you want to verify if I can use the horizontal strip, so you may also do that one. But it's obvious that at the bottom part of the graph, the right and the left portion of the horizontal strip is now touching the same graph, diba? Which makes it invalid, because if mag x right minus x left ka, that's going to be 0, right? So that's why it's impossible to use a vertical strip, rather horizontal strip in this problem. Okay, so the first thing that we need to do is to solve for the area. So let's say these are the points of intersection. So again, these solutions or the graph here, I leave this one to you. So always show the solution here. So let's say this one is -2 and then -4, -4 first, and then -2. And the other point would be this one, 8 and 8. All right, so again, since we are using the vertical strip, so we look first for the area. So area is integral of, so again, since we are using the vertical strip, that would be y top minus y bottom dx from x1 to x2. And then this would be now equal to, so again, y top is the blue graph. And again, this one is in terms of this format now. So you're going to have it as x over 2 plus 4 y top minus y bottom. That would be this one, the red graph. So y bottom, and then this one is y top. So this is now x squared all over 8. And then dx. So again, x1 to x2. So this one would be x1, then going towards the left side, x2, x sub 2. So that would be from negative 4 going to 8. Then the area would be equal to okay, so what's the answer?
$36, sir.
Okay, so it's 36 square units. So always write square units since we are looking for the area. Alright, so this is the first step again. You just look for the area. Diba? So again, what we have discussed before is still useful in this topic. So the next step is we're going to, so this one is the area, 36 square units. So for the next part is again, we're going to go back to the formula given in locating the centroid. So now since we have found the area, which is 36 square units, so let's try to write it above. So area is equal to 36 square units. Okay. So the next step is you solve for x bar or bar x or bar and then bar y, or bar y first and then bar x. So whichever you like to solve first, as long as you're going to solve both, diba? So kailangan to isolve ang x and bar y because that would be the location of the centroid. So we need both coordinates to locate the centroid of the bounded region. So we need to solve bar x, we need to solve bar y for us to be able to locate the exact location of the centroid. So let's say we're going to solve first bar x. Okay, bar x first. And then afterwards, we're going to solve bar y. So you're going to see the difference in the formula that we're going to create in both bar x and bar y. So bar x times area, again, the whole is equal to the individual components, x sub c and then differential area. Okay, so again, since we are using the vertical strip, so our differential area will now translate into, again, the same formula is equal to x sub c multiplied by y top minus y bottom dx from x1 to x2. So again, our dA will depend on the strip that you're going to use. Okay. So next is bar x, then multiplied by the area, which is 36 square units, is equal to bar x, x sub c. So x sub c is the location of the centroid of the strip that you are looking for. So again, since it's a representative of an individual component, so let's say this one is your vertical strip, and then this one, let's say, is the centroid. So towards the centroid of the vertical strip, what is the location of its centroid. So meaning this one is just x variable, diba? X units. Meaning x sub c is equal to x units. Because we don't know the exact value of that particular centroid of the vertical strip, diba? So meaning x sub c is just x variable, and then the other components will repeat itself, y top minus y bottom. So x over 2 plus 4 minus x squared over 8 dx from negative 4 to negative 8. So again, x sub c is the distance of the distance x going towards the centroid of the strip you are using. So again, since this one is a vertical strip, and then let's say this one is a centroid, going towards the centroid is x units. So that's why x sub c is equal to x units, and that's why here in the formula x sub c is equal to just x variable, x units, because again we don't know the exact value of the location of the centroid. Okay, so with this, I think you have to solve first the right hand side and then divide everything by 36. Then you're going to get bar x. So try this one in your calculator.
Sir, negative 8 na, sir, or 8?
It's 8. It's 8. Okay, so what's the answer now?
2, sir.
So this one is 2 units. So always write the unit, ha. So buting apelido, 2 units to cm to millimeters. Okay, so this one is the answer. So 2 units. So again, notice that instead of this one being bar x, this is bar x sub c na siya. So again, going towards the centroid of the vertical strip. Okay, so let's go now to the other formula, which is bar y. So bar y times the area is equal to the integral of y sub c differential area. Again, since we're using a vertical strip, this would be in this format now. So y sub c, then y top minus y bottom dx from x1 to x2. Okay, so this time, since we're looking for the centroid of the vertical strip, y sub c, so since this one is y sub c, so this is not going to be y directly, diba? Because we are in terms of x. So I think that's a difference in solving both bar x and bar y. So the other bar location would be complicated compared to the other one. So kanina is since we are looking for bar x only, so dito siya x units, di ba? X sub c is equal to x only. But notice this time, since we are in the y direction, and we cannot just simply say that y sub c is equal to y, because if we try to replace it in the formula, we are integrating with respect to x. Diba? So we cannot just declare directly that y sub c is y units. But of course, it's correct to say that y sub c is y units because it's in the vertical direction. Diba? But again, since if you're going to replace y in the formula, diba, y sub c, we cannot integrate because we are integrating with respect to x. Okay? So I think that's what you need to be aware of in the formula. So to solve this one, in the bottom part of the strip, the location towards this point here is um, y bottom, di ba? On this part of the strip. At the top of the strip, that would be y top. So of course, to solve the center point, di ba? To solve the center point of the strip, so we're going to use the average of the two distance, di ba? Or distance formula, di ba? Not totally distance formula katong squared, but you just have to um, get this one first, di ba? Y top, the distance going towards y top, and then subtract it with this portion here, y bottom, and what you get is the distance of the strip, diba? And then you divide by 2 for you to be able to get the centroid. So that's why the formula will be even more complicated. So it becomes bar y times area is equal to y top minus y bottom divided by 2 times y top minus y bottom. It's y top plus y bottom. You're going to plus the 2 there, and then divided by 2, and then dx. Okay. So that's how you're going to create your formula. Okay, so kindly mute your mic. So going back to the discussion, so bar y, and then our area again coming from the previous solution, it's 36. So this is now a complicated formula. So y top, so you're going to have it as x over 2 plus 4, and then plus x squared over 8, then divided by 2. And then y top minus y bottom, so this is x over 2 plus 4, and then minus x squared over 8, and then dx, going from negative 4 towards 8. So again, we did not make y sub c equals to y because again we are integrating with respect to x, and there will be an argument between the variables because it should all be in terms of x. All right. So since this one is complicated, and I know that the calculator is powerful, but try simplifying this one first before plugging it in the calculator para at least makatabang pud mo sa inyong calculator somehow with the answer. So bar y is equal to, I think, so I'm going to answer this one since this one is complicated. It's 1.2 units. It's 3.2 there, 3.2 units. So 3.2 units. So again, notice that we are um, so again, try simplifying the equation first before plugging it in the calculator. So again, I think the main tip here would be to graph, to solve for the area, then bar x, and then bar y. So this one is a bit longer compared with the other topics because you're going to have plenty of solutions for this type of problem. And another tip here is you're going to use one strip only. One strip only. Or let's say one kind of strip in this topic. So if you're going to use horizontal strip, you're going to use horizontal strip in finding the area, finding the bar x, finding the bar y. So you cannot shift from other strips in the process of locating the other aspects of the centroid. So dapat you're going to use one strip all throughout the method. So in the area, if you're going to use a vertical strip, so dapat bar x and bar y should also be in a vertical strip. If you're going to use horizontal strip, so horizontal strip for the area, for the bar x and the bar y. So you have to be consistent. So only one kind of strip to be used in this type of problem. Okay, so let's go to this problem now. So we have to locate the centroid first. In the previous problem, your final answer may be expressed in this format: bar x, bar y. Therefore, bar x, bar y is equal to 2 and then 3.2. So you can summarize your answer in this format. Okay. Okay, so let's go to this problem. So we're going to find the centroid here. Y squared is equal to 4x and bounded by the curve, and then the line x equals 0, or that would be the y-axis, and then y equals to 4. So of course here we're just going to use the vertical strip, but you may also use the horizontal strip as well, because if you're going to create a horizontal strip, notice that the right and the left portion are consistent, diba? So the right one is the red graph, the left one is the y-axis, or x equals 0. For the vertical strip, the top portion is the purple line, which is y equals 4, and then the bottom part of the strip is um, the curve, which is y squared equals to 4x. Alright, so since we are using, so later on when you try to review this topic, so try solving this one using the horizontal strip. So again, area, solving first for the area using vertical strip. So this should be y top minus y bottom dx from x1 to x2. Okay, so the formula would be um, y top is the purple graph, that would be 4, minus the bottom part, which is y squared equals 4x, and then rearranging it to become a y only. So this is 2 square root of x, and then dx. So again, x1 is on the left portion, that would be 0, going towards the right portion, 4. So this one is 0 and 4. Let's say 4 and 4 rather. Then this one is 0, 0. And then the area would be equal to blank units. Okay, so this should be 16 over 3 units. Okay, or 5.33. So let's try to write it here. So 16 over 3 or 5.33 units. So I usually, since since I'm not looking for the area, so what I'm going to do in my formula is that I'm going to use 16 over 3, but at least delicate siya rounded off when I try to look for the bar x and the bar y. So at least tibuok fraction sa ako ang gamit dili itong rounded off na decimal number, diba? Okay, di ba 16 over 3 is 5.33333. So at least masin maka-help pa rito, let's say in terms of decimal places or decimal points, ang atong extra 3s, di ba? So that's why I try to use it in fraction first, and then I try to make my final answer in decimal in the last part na katong bar x and then bar y. Okay, so bar x first. So again, it will depend on what type of area you're going to use. So again, since we're using the vertical strip, so this one is now x sub c and then y top minus y bottom dx from x1 to x2. Okay, so bar x is times 16 over 3. And again, if it's vertical strip, so that would automatically be just x because this one is the centroid. And then again, since we are in terms of integrating with respect to x, so automatically this one is x variable. And again, it's not x right minus x left because the strip is standing, diba? So it's direct to the point. So probably if para di mo maglibog, try to imagine this one as a line, diba? If line siya, and this one is a centroid, so of course going towards the centroid is x distance, diba? Okay, so x distance, and then again going back to the formula, that would be 4 minus 2 square root of x and then dx from 0 to 4. And then bar x is blank units. Okay, so the answer would be 1.2 units. And then this is the answer. So again, it's not x right minus x left because again, the strip you're using is vertical, diba? So there's no distance to be measured out. So so again is try to imagine the strip as a line. So let's say this one is the line, diba? And let's say this one is the centroid. So going towards this location is x distance. But let's say going towards the centroid in the y aspect, you have to determine first that this one and then also this one, diba? Then divided by 2 to locate the centroid in terms of y. So, diba? So if x put, so of course, that would be another story, diba? Let's say this one is the x line, this one is the centroid. So in terms of y, so of course, automatically y, diba? But for the horizontal distance, you're going to average it first, diba? So distance of this one, and then distance of the other one, divided by 2. Diba? So I think you get the point, diba? So magana siya pag-explain why the other one is not x right minus x left. So if you want to x right minus x left, so you have to use the horizontal strip, which is the other solution to this problem. Okay, so bar y, I'm sorry. So bar y times the area, then y sub c, and then dA. So pwede mo maglibog, just get the average lang without totally understanding it if you want it in that particular manner, di ba? If you don't want to understand it, so just take the average of the y top and y bottom. Ano. So bar y times 16 over 3 is equal to, again, this one would be y top plus y bottom over 2, then y top minus y bottom dx from x1 to x2. Okay, so bar y again is 16 over 3, the area. Then integral of, so y top first, so 4 plus 2 square root of x all over 2. So again, notice that I try to write as many parentheses as possible, okay, para I can locate it later. Then 4 minus 2 square root of x and then dx. That would be from 0 to 4. And then bar y would be equal to, I think it's 1.2. It's 1.2 units. All right. It's 3 day. It's 3 units. Naunsa naman akong pen eh. It's 3 units there. It's not 1.2. So it's 3 units. So I think the diagram is actually explaining this one very well. So y top, diba, distance, then plus the distance in the y bottom, and then you take the average, diba, divided by 2, and that would be y sub c. So just try to change this one into y sub c. It's not really bar y, but it's y sub c. Okay, so let's try the horizontal strip this time. So again, with the same location, with the same, so this one is 4 and 4, and then this one is 0 and 0. So this time, horizontal strip, x right is the red graph, x left is the green line, which is x equals 0. So in solving the area, so hopefully this one is the same, diba? So of course it's really the same, okay? It can be solved using the horizontal strip, but try to verify this one. So x right minus x left, and then dy from y1 to y2. So x right is the red graph, which is now y squared over 2, over 4 rather. So notice that it's better to look at, diba, because there's no radical expression. And then minus 0. So notice it's minus 0 on the left part. So it's super easy to integrate, diba? So from 0 to 4. Y squared over 4 dy from 0 to 4. Which I think you can integrate this one manually gani if di mo gamit the calculator. So 16 over 3 units. So I think again this is where the advantage of using the other strip comes in. As what I have told you in the previous discussion, so it may be advantageous for you to use vertical strip because it gives you a simple expression of the equations, or the horizontal strip may give you the simpler expression compared with the vertical strip. So again, you have to be observant with a given equation. Try to express it in y in terms of x and so of course, we're not going to be determining the area by expressing the equations in which is easier in terms of x power in terms of y. But of course, you have to also examine the bounded region if both can be used, diba? Both vertical strip or horizontal strip can be used in the problem. So what if vertical strip lang pwede and then you are forced to use a complicated expression? So of course, there's no choice, diba? Because we cannot use the other strip which gives an easier expression. So ano na siya? So you have to be very observant with the problem, Jud. With the strip you're going to use, with the equations that you're going to input in your calculator. So muna siya. Okay, so still 16 over 3. But again, if you compare this one with the vertical strip area, so probably this one is a simpler expression compared with the vertical strip. Okay, so um, bar x, oops, sorry. So bar x and then the area. So x sub c differential area. So again, since we are using the horizontal strip, this becomes x sub c times x sub r minus x sub left dy from y1 to y2. So this time, since we are now using the horizontal strip, we cannot use directly x variable as our x distance, diba? Because we are now in the x aspect. So x sub r, then this one x sub left, then you take the average, diba? Since we are now in the horizontal aspect. For the bar y, or for y sub c, so y sub c is just this one, diba? Equals to y units. For x sub c, that would be the average of xr and x left. So notice that there's a shift aside in our solution, diba? Ganina, when we are using the when we are using the vertical strip, x sub c is just equal to x. But this time, x sub c is now equal to x right minus x left divided by 2. Diba? So x right minus x left plus x left divided by 2, and then x right minus x left dy. And this one is bar x and then the area. So again, 16 over 3 is equal to, so again, x right is equal to y squared over 4, then minus 0 divided by 2, and this one is y squared over 4 minus 0 dy. And then bar x is equal to the same, which is equal to I think it's 3 units. 3 or 1.2. So this one is 1.2 units. This is the same as the vertical strip. Okay. Then for the bar y, so bar y times the area is equal to y sub c times the differential area. So this becomes bar y times the area. Then again, since we're using the horizontal strip, so y1 to y2, y sub c times x right minus x left dy. Then bar y times the area. So y sub c is just equal to y. Because again, we can average something of out of the line, diba? Y. So 0 to 4, uh, this one is just y, diba? So bar y times 16 over 3 equivalent to 0 over 4 y times y squared over 4 minus 0 and then dy. So notice that this one is a bit simple, diba? Compared to the other one, which is, I think you are going to multiply with a radical expression. So 3 units. And this one is the answer. So again, um, try to simplify the equation so that you can help the calculator in getting the answer a bit quicker. Okay. And I think this is the problem set, which is I'm going to post later on. So I think your main concern would be graphing the equation should, because I'm not really sure if you know how to graph or if the graphing topic was introduced in the senior high. Because I think if you know how to graph, probably the all the topics after the midterm exam would be super easy because it's more on the graphing aspect, and then since the formula is just there and then you just have to use the calculator, so I think that would be the easy part, diba? But I think the difficult part would be graphing the equations. And again, you have to provide evidence for graphing the equations, diba? Not just the graph magically appearing in your paper. Okay, so to sum it up all, so vertical strip, so bar x is just to summarize the formula, bar x is x times y top minus y bottom dx from x1 to x2. And then bar y is the complicated version, which is y top plus y bottom over 2, and then y top minus y bottom dx x1 to x2. That's for the vertical strip. For the horizontal strip, the summarized formula would be bar x times the area. So this one is now x right plus x left over 2, and then x right minus x left dy from y1 to y2. So notice if you compare both bar x, di ba? Masyag opposite of the other one, di ba? And then bar y is y only, di ba? So ganina x to ang horizontal strip, and then this one is x right minus x left dy. And then this is y1 to y2. So that's the summarize or the summary of the formula. Kana mga no-brainer kana di nakaganahan mo kuan, di nakaganahan mo sabot jud sa concept, so just use the formula directly. But of course, you know, dapat kiwasan mo mogamit sa formula. Di lang kay plug in lang bisag unsa, di ba? Okay? So I think that would be all. So I think probably again the challenge would be graphing the equations, especially number 2. So di ba? Kani siya triangle mo na siya. Siya ginana. Let's say these are the 3 points. So of course, if you're going to use vertical strip or horizontal strip, so kana magdepende na siya sa ano niyo pag pag figure out. Diba? Okay. Again, since we are looking for y top, y bottom, x right, and x left, so meaning these lines must be expressed in equations, di ba? Katong y equals mx plus b. Ano. So, muna siya ang challenge yun. Okay? So, do you have questions before we leave?